chapter 14, the last one, sets. So set is kind of similar to dictionaries, but it has its own pros and cons like the dictionary. So many programming languages offer sets. Python also does it without getting failed. So you often use sets when you try to find a unique records within the sets. So let's say, for example, if you have keys in terms of sets, so you can actually compare the keys with a different data set and try to see whether they are unique, or is there any common fields under those keys or not. So that is a practical example of how to use sets. So basically you will use like I said, you will use the combination of these data types to fit for your purpose and try to make a better use of it. The syntax is kind of similar to dictionaries. You will have flower brackets, but you won't have the colon separation between the key and value, so you will just only have the element. So this is a typical example of a set. Let's see that in practice. So first line, it's gonna assign different elements to the set, and we are just gonna loop over each and every element. So I'm just using the for loop, and we are gonna print each and every element of the iteration. I believe it has to be like this. And so we are gonna list the fruit set output. So we are doing this in order to make it sortable, like the dictionaries. The sets are not gonna be ordered, so uh, you need to have it to be converted to list and sorted, and use it for the print statement. So we can see these difference in action. So the order is A B C D M. So let's see how it's gonna print. So when we print for the first, so they printed randomly rather than how we entered the data here. But when we organize it, so we can see that the order is pretty much alphabetic. So that's the purpose of using list. We call it as type listing. So we are converting the fruit set to list and sort it, and then use it for the for loop statement, and that pretty much helps us to kind of use the sort for the sets, but not directly in an indirect way. So we have methods like we've seen in other data types like add, update, remove, discard, and clear. They are the most common, but not all of them. We cover the major methods that we are going to use. So this is a typical example of how to use add and update. See that. So let's see what's done here. So we are just having the fruit set created, and we are just printing to see how it looks like. So we are gonna add apple element to it. So like I said before, sets contains unique elements in its fields. So if you try to add something that already exists, it's not gonna take it. If you add something different, it's gonna take it, but not in an orderly fashion. You cannot access in a like indexed. So it won't be indexed, but it will be there. So when you print it, you can see that it will be added there. So when we try to update with a bunch of elements, it's basically going to take it if it doesn't exist. So let's see how this looks like. So the first print, we don't see that apple is going to be added again, so that's fine. And elderberry, it's added, but it's not at the end like we expect from other data types. And this thing is update output, and it basically takes the intersection of the existing elements and the elements that are new to it, and it will be added to the set. So let's proceed with the next one. So we seen how we will see the difference between remove, clear, and delete at later point. But let's just take a look at it. Basically, it's gonna we don't have to check it. It's basically gonna remove the apple from the fruit step. So this is the difference I'm talking about. So if you try to remove something that doesn't exist, it's gonna throw a runtime error. If you use a discard method, it's literally not gonna you know go over the trouble of throwing an error. So clear is not going to take an argument. It will, I mean, it's not going to take a particular element to remove. It's just going to basically remove the entire set once and for all. So we seen pop method, no need for particular explanation of that. And copy is to just to copy, create a copy of the set. So one more important method that we are gonna come across is in an intersection. So like I said, we are gonna see sets being used to identify unique records. So obviously we need to use union intersection methods to do that. So this is alternative of using the keyword dot union. You don't have to do that if we use this. So or you can, yeah, you can use either or. So also there is an intersection and a difference finder. So let's see how it looks in action. So this is gonna print banana and cherry, that is in common. So the difference between these two sets is gonna be apple. Rest of them are like pretty much common. You can see that durian is missing, but when you try to use the different, it will find the different that exists in the first argument comparative to the next. It is like a left join if you if you know how to use equal. So speaking of joins, we will also come across these three different methods. So let me walk it through. So if you use is disjoint, um, like I said, it's like a difference, but it's gonna return a boolean output comparative to the difference that we seen just now. So is subset and is superset is like uh, uh, inversely proportional operation. So let's see, that makes much sense rather than trying to explain. So is disjoint is gonna return true if all the elements in fruit 1 is unique to fruit 2. So that's going to be false because we have cherry in common, and we're trying to see fruit 1 is subset of fruit 2. uh, let's see. Well, that's not going to be true because we have three elements. It's not going to be a subset of 2 if there are like less elements inside the set, inside the sets. So fruit 2 is subset of fruit 1, probably, because yeah, that might be true. Let's see that in action. Yeah, it's true because its two elements exist in true one. So rest of them are self-explanatory, so we don't have to go over all of them. Let's move to the next one. So we can also come across something called frozen set, which is basically try to make the elements immutable. So you can see that the sets are mutable, but it's gonna take the unique argument. So what if I want to have an immutable property? You have to use the method frozen set. So once you call this function, so basically you have to pass these elements which will be immutable, and yeah, when you try to make an operation out of it, it's not gonna make any operation on top of a frozen set. So that would be the end of our session.